Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome to the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. Thank you for joining us. I'm your host, Ben Crossman, and everyone out there, I hope that you're doing well, you're having a great day, and hey, you're ready for some Computer America, where in the second part of the program, we'll be doing computer and technology news. Anytime that we have left, hey, we're going to try to keep you up to date on the latest tech stories and things like that. I mean, we follow it all day long, and we can barely do it. We can't imagine having a job and, hey, being able to follow the tech news. So we'll try to keep you up to date. So that's in the second part of the show. But in the first part of the show, we will be entirely dedicated to our guest, and our guest is going to be none other than a board member of Vesa, and we're going to be talking all about the Video Electronics Standards Association. It may not seem like it. This is a very to some people, this can seem like a strange show, but whenever we have a lot of the associations in charge of standards and that kind of thing, they're actually some of our best, because it's a way to talk about the actual state of technology, and maybe not where it is currently, but where it's going to go. Once you set a standard and once enough manufacturers and businesses and whatnot sign on to that standard, hey, then that's what you're going to be seeing in the coming year. So this is a little bit like seeing into the future, and of course we will be talking about a lot. So before we get started, computeramerica.com, you heard it in the intro. You'll find show notes for today's show. If you'd like to check out any links to any articles or guest website, be sure to check out computeramerica.com after today's program. While you're there, check out some of our articles. We have reviews, we have topics. Hey, we just got a couple of books in, and we're going to try to, get through those and of course get them on the show, but hey, put reviews up on the website as well. A lot of interesting stuff, and always computeramerica.com. Find us on social media, blah, blah, blah. Okay, now, with that being said, why don't we go ahead and introduce our guest. And as I said before, of course, board member of Vesa, but also he is the Senior Director of Marketing for Parade Technology, which we'll get into a little bit as well. So let's go ahead and unmute. We should be good. We should be good to go. Craig Wiley. Hey, welcome onto the program. How you doing?
Hey, hi Ben. Thanks for having me on. This is a fun show, and this should be. I think your listeners might find interest in what's coming on the display interface side.
Absolutely. This is, and of course, this is a bit on the tail of CES. We were out there at CES, and that's how we were able to get, some cards out there and have you on the show. And display was everywhere. I mean, everyone had a new gaming monitor. Everyone had a new 120-inch. Everyone had a new 8K, monitor. Different standards, different technology that people might not have heard of. And I thought this would be a very interesting show to, kind of talk about what's coming up. But before we do that, let's talk about some past, and let's talk about your background. How long have you been, of course, with Parade, and how long have you worked with Vesa, and have you always been in technology?
Yeah, well, as a kid, I was the ham operator in the neighborhood, and I was able to fix everybody's car stereo.
Surprising number of ham operators listen to the show. We have a very robust community. Like, it surprises me because, we talk about all the latest tech, and then they're like, oh yeah, the busiest room is the people talking about ham radio. It's still big, but I'm sorry, go ahead.
Yeah. Well, it's a fun hobby. I mean, I'm actually an extra class. I got that years ago.
Nice.
But yeah, so I've been in the semiconductor industry since 1980, actually, and got into video interfaces back in the 90s, and then worked with the analog interfaces. I actually worked with the standard for HDTV broadcast before it came out.
Mm-hmm.
And then got very involved with integrating the video encoders and video gen locks and all that kind of stuff in analog. And then been with industry as we made a transition to digital. And then, as computers became more visual, got very involved with display and visual processing support in computers. And we're right in the middle of all these high resolution display technologies right now, where, now you're seeing 5K and now 8K. And the new DisplayPort standard, which we'll talk about, will actually drive 16K. But that's a ways off, I'm sure.
Yeah, and that it kind of is and it kind of isn't. I mean, I remember just a couple of months ago, if not just last year, we were talking about 8K, and when I mentioned to some of my other kind of correspondents that we have on the show, I mentioned 8K, and they all laugh and they go, 8K, where does it end? And then you are officially the first person to come on the show and mention 16K. So hey, little milestone there. But I mentioned that because last year it was a joke. This year, probably more towards the holidays. I mean, you could definitely buy them now. They're very, very expensive, but they're going to be more common coming this holiday. So 16, you say, comes away ways off. It's not that far off though, right?
Yeah. And for me, where 4K has always had the most application is actually on your desk. If you're looking at a 27 or 32 inch monitor in your desk, the size of the monitors and the dots per inch you get is really useful. If you have a typically sized screen, even it's sometimes hard to see the difference between 4K and 1080p, but already you're seeing 8K monitors. And if you put a big monitor in your desk, you can actually see a difference between 4K and 8K. And a lot of that is because of the display size. 16K, I mean, the fact that we could do 16K with the standard, that really reflects the fact that we can support more than 8K at 60 hertz. So if you had a gaming monitor, you can go at higher refresh rates, you can go at deeper colors or multiple monitors. All of that requires more bandwidth. Now, in the TV side, actually, Japan will be broadcasting the Olympics, the summer 2020 Olympics in 8K. Just like 4K was first broadcast, I think, in some of the Olympic programs as well. Partly for 8K on the television side, it's a lot of it is to sell an upgrade. And so it's questionable if it's usable depending on the screen size, but certainly on the desktop for productivity, even spreadsheets that are large, this is where your high resolution really comes into play. It's like phones. People didn't think that phones had to have 4K resolution. So if you look even at a 4K, if you look at a 4K, even a 13-inch notebook, you'll see a difference. I mean, it's sharp, right? And so that's the idea. If you have a big screen at 8K, that's like having a small screen at 4K. So this is where 8K will be coming, and then transition to 16K, who knows?
Right. But sadly, I didn't hear any mention of 3D, so unfortunately, we'll have to wait a little bit more for that. I will say, though, that...
Well, that'd be VR. Well, okay, the other thing that you can do with DisplayPort is you can send multiple streams. And some people feel that 10K or 11K is about the threshold for VR where you would need to be for realistic 3D. But that's a whole different thing. But we support VR also.
Sorry about that. It's and really when people mention like 10K, 11K, I think that those are pretty arbitrary. Like I know that it's like that's all your eye can perceive and stuff like that. But it wasn't that old wives' tale that, you can your eye can only see 30 frames per second. Anything more than that is just wasteful. But of course, now 144 hertz refresh rate monitors are probably one of the best investments you can have for displays. At least it seems to me, because I recently bought one and I want to justify the money I spent. So I will say, though, that all these different standards, and we mentioned a lot of different acronyms here, and we're going to get into that. Let's talk about the Video Electronic Standards Association, Vesa. People may have heard things like Vesa compliance and things like that, especially when it comes to like wall mounts and whatnot. But talk about the organization and what its mission is. Like, why does it exist, and who are its members?
Well, if you're thinking about companies like Intel and Dell and Apple and Nvidia and all these companies, they don't want to invest a lot of money in something, particularly an interface to a display, unless everybody else in the industry agrees on it so that they can interoperate. Mm-hmm. So actually, 30 years ago, back in 1989, Vesa was formed by the computer companies at the time to establish what's called EDID. And basically, that's the plug and play aspect of a monitor, where when you plug it in, your computer knows it's there, it knows what the resolution is, and then it provides the proper video. So that's actually where it got started. And the industry wanted a standard so that third parties can sell displays to computer companies and everything worked together. And then it went from there. You've probably heard of the Vesa hole mounts or the brackets that hold on the computer. And then we did there's a whole list of standards if you look at the I guess it's on the Wikipedia page. But,
and of course for people watching the video portion, and sorry, just real quick, but people watching the video portion, you can see your DisplayPort, DisplayHDR, and stuff like that. But yeah, please go ahead.
These are the main ones. So a lot of the effort in the last 10 years has been on DisplayPort. So DisplayPort is the computer interface, which we can get more into, but there's reasons why DisplayPort exists. And I can get into that later, but DisplayPort is a video interface that's now supported by USB connector. So devices with the new USB 4 connector, for example, will have DisplayPort, as well as the ones today. It's called DisplayPort Alt Mode. We also standardized the performance for HDR monitors, and HDR is high dynamic range. And these are the new monitors that give you very lifelike colors, so the brilliant, realistic color, a lot of contrast, and we kind of set the standard for the benchmarks that those displays need to have to get certified. Mm-hmm. And then we've also developed compression technology. It's a visually lossless compression. It compresses the video rate by a rate of about 3:1, and this allows higher resolution to exist over existing display interfaces, and it's used by HDMI. It's used by another standard organization called MIPI. Mm-hmm. So basically, it's a group of industries. We're now 290 companies. The main companies are companies like Intel, Nvidia, Apple, AMD, etc. Dell, Sony, Panasonic. Pretty much anybody involved in electronics that has anything to do with displays. And so these are the leading companies that work together to define where we're going in the future, and then they work towards developing the technology. And then we're also a marketing organization where we demonstrate the new technology at CES. Mm-hmm. We work with the media, and then we publish a spec. And then the members join basically to have access to the specifications that we develop. And then also we have a certification program. So standards like DisplayPort and DisplayPort and DisplayHDR can be certified. So then the products will get a logo, and then you'll know that those products actually meet the standard, and they should interoperate with other products that also meet the standard.
And really, I was just thinking back to when I went to, and I believe it actually was the DisplayPort booth at CES, and there was a gentleman there who was talking to the PR rep who was manning the counter. I don't think that she was actually too well versed on the technical side, but the gentleman talking to her was definitely not versed in it, and he was trying to get he was trying to get a reason as to why, one company does this versus that, and essentially he was confusing what a standards organization does versus what the individual members do with their own technology. Like, kind of like you mentioned with Apple and their displays, Microsoft and their displays, Dell, and so on and so forth, the ones that actually make the displays. That's where the variance is. Like, that's why we don't have a market full of just the exact same monitor. Everyone's allowed to do their own thing. They just have to meet a minimum requirement to be able to say we are, DisplayPort, compliant, right?
Yes. Yeah. There's DisplayPort has a protocol where there's a lot of registers and stuff that the control point on a display is actually your computer. And what it does is it reads registers in the display to understand the capability of the display. And then once it understands the capability, like, okay, you support this refresh rate, you support this color space, then it will write registers to configure the display appropriately. And then it uses more protocol to then start the display, all that kind of stuff. So what the certification does is make sure that the protocols on both sides, in other words, on the video source side and the sync side, are handled appropriately so that they'll talk to each other. If not implemented correctly, you can have a problem. You may not light up your display, or if you're changing resolutions, you may get a distorted picture or something. So the idea is to make sure that things are functioning properly. It's like if bad firmware was in your car and at 60 miles per hour, so it would just stop working. You wouldn't want that, right?
Right.
So the idea is to kind of verify proper operation, and it's basically you want a seamless experience for the consumer when they come home and plug it in and it just works. There's a lot of complexity behind the scenes, and to the consumer, it should just work, and that should be the end of the story. And that's what we make sure happens basically.
And you just put it right there. That's why I love standards, is that I do really just want things to work. I get annoyed when my monitors, because I have like a 3-monitor mount here, they aren't Vesa compliant, and it just irks me up a wall, because that monitor might as well be useless to me. Compliance or standards are good, and that's for sure. Now, speaking of standards, and we mentioned HDMI and DisplayPort, I think a lot of people are familiar with HDMI cables. DisplayPort, maybe not so much. Let's talk about the difference and why, according to my notes here, why the industry is actually looking to prefer DisplayPort over HDMI.
Well, so HDMI has been around for a long time. It was actually, well, if you go back pretty far, you have VGA, which is an analog standard. And then DVI was effectively a digitized version of VGA. And then HDMI added sound. And what we have today with HDMI 1.4a, which is kind of the base standard, that's kind of been around since the early 2000s. And some of the challenges with it is that I don't mean to get too technical, but it's DC coupled, and it only supports one stream of video, and things like that. But the thing about it being DC coupled is, in the old days with larger chip geometries and higher voltages, it was fine. But DisplayPort was built to be AC coupled to work with much smaller signals, so that it can be integrated into chips. So Intel can integrate it onto their chipsets. They have the integrated GPUs. The GPU vendors like AMD and Nvidia can integrate it into their chips. Qualcomm can integrate it into the chip that goes in the phone. So basically, it was meant to be integratable, and it was also designed to use packets rather than just streaming video. And by using packets, it was much more expandable. So we can keep adding features to it. And when you connect a display to a source, it can figure out what features it can support, and then it could basically extend its capability. Whereas with HDMI, it's more of just a fixed standard that isn't flexible that way. So DisplayPort was built with the idea of using modern process technologies, highly integrated chips, to go on to integrated chips, and also be continually expandable to allow things like, high resolution. We can do 3D like what you're talking about.
Mm-hmm.
Now, what HDMI has done is HDMI now has done a new spec called HDMI 2.0 and 2.1, which is an extension of what was HDMI 1.4. But HDMI 1.4 still has to be supported. So there's still the backward compatibility stuff. And frankly, HDMI is actually is licensed by a private consortium. And so there's licensing, there's royalty, and it's that sort of thing, where DisplayPort is royalty free. It's a group of companies who wanted to promote a standard that's not in the business of selling the standard, but basically in the business of providing more capability so that they can continue to innovate in technology and provide basically better user experiences, and not make it a business to sell video, but basically have an agreement between other companies to promote a standard. So because of the flexibility of DisplayPort, when the USB-C connector was introduced a few years ago, DisplayPort was also incorporated onto the USB-C connector. So a lot of computers now will only have the USB-C connector, and that's also your video connector. And a matter of fact, if you have a phone with a USB-C connector, that also has DisplayPort coming out. So if you connect like a USB-C to DP adapter cable, you can plug that into the display, for example. And now the USB 4 standard, USB 4 not only has what's called the DisplayPort alt mode, but they're doing something now which is called DisplayPort tunneling. And this is allowed because since DisplayPort is a packetized protocol, and matter of fact, this first started with Thunderbolt. And now this is the same thing. So that same packetization approach is now used in USB 4, where you can, through USB 4, you can have PCIe, USB, and DisplayPort packets all coming down the same wire. So that'd be one wire to a docking station with all that data. You have basically, storage data, other data for USB and video, and then also power, of course, so you can charge your PC. So DisplayPort was really kind of developed for the needs of the IT and computer industry, and for the needs of integration, and for the needs of something being flexible. And we weren't constrained by certain technology that had licensing costs that we wanted to hold on to. We just basically wanted, the industry had an interest in just promoting something that kind of would allow the industry to advance. Now on HDMI, one last thing in HDMI is that in HDMI, there's many more HDMI devices. And if you look at your audio video island, you may have like a PlayStation, a DVD player, an AV receiver, all which have DisplayPort plugs on them. And so there's a need to kind of keep that whole backward compatibility there within that island of devices. Where on your PC, it's not necessarily true. But the other thing we built into DisplayPort is we built in the ability to do protocol conversion. So if you plug in like a DisplayPort to HDMI converter dongle, it actually detects the dongle and then configures the video to be HDMI friendly, and then basically provides HDMI conversion at the dongle. And that would be, for example, if you had a PC that had an HDMI input, or if you had a phone or a laptop where you wanted to show video on an HDMI TV. So we built in that capability. You can also get like even DisplayPort to VGA. So we wanted to be backward compatible with these existing devices, but we also wanted to move forward and provide better performance, higher integration, and just more flexibility, basically. So that's kind of how DisplayPort came to be.
Yeah, and you said that very well. There's a lot to cover there. I guess one of the things there is that I know that on a lot of higher-end graphics cards, DisplayPort has been a thing for a little while now, and I guess as graphics cards continue to kind of develop. So far, it seems like many graphics cards out there support both DisplayPort and HDMI at the start. And this is just your opinion, obviously, as a guest on the show. You think that, do you think that there's room for two standards? Because, to the consumer, the cords look really, really similar. Like the actual cables won't fit into each other's sockets, but they're really, really close, and I guess they kind of do the same thing. Even though I guess DisplayPort, like you said, is preferred by the industry. HDMI is very, very ubiquitous. Like I know a lot of people who say, "Oh, that other HDMI," when they talk about DisplayPort. We're going to see both for a while now, right? Like it's not like tomorrow one's going to die and the other is going to thrive.
Well, a lot of us who work in DisplayPort are also involved with HDMI, and there's companies that make gaming, companies that make gaming consoles and monitors do want to continue to support HDMI for both backward compatibility. So because HDMI is so ubiquitous, it really is, it's not going to go away anytime soon.
I gotcha.
And as a matter of fact, HDMI is doing many of the things which DisplayPort has already done in terms of using, kind of how the interface works and the compression and things like that, the variable refresh rate, the color space. The TV industry is the one more driving HDMI, and as far as gaming, it would be to support gaming consoles and things like that. So they do want, like adaptive sync. Basically, HDMI has its variable refresh rate stuff. So there's a kind of a lot of commonality, but you don't see. Well, and as far as HDMI being on PCs, a lot of times when you walk into a conference room at a company, they hand you the connection to their projector, and it's an HDMI plug, right? And so this is why a lot of the business computers still have HDMI outputs. Of course, HDMI does want to push monitor makers to have HDMI in their displays too, because they get royalty for that. So
right.
there's an interest in doing that. But really, the most of the key people making the decisions on HDMI tend to be oriented around the television, either to support gaming or to support 4K, 8K displays and things like that. The DisplayPort players are more the PC industry and the PC monitor makers and the docking station guys. And this is why now you'll see that the emphasis on DisplayPort is really going to the USB-C connector, because more and more computers are going to get smaller. We want less computers. And if you get down to the size of a phone, phones have one connector, and that USB-C connector will do everything you need. So they'll continue to exist, and there's some overlap. But certainly, TV makers aren't looking at DisplayPort. Again, their island is more the HDMI standard, whereas for PCs, it's DisplayPort and now USB-C.
Yeah.
So there's some overlap, basically.
I completely understand, and of course there are things like mini DisplayPort, which you mentioned for mobile devices. Maybe that might be an option, but I guess, like you said, actually Europe just did a thing the other day. I'm sure that you and your organization are very in tune with that. I think Europe said that they are going to mandate that all phones at least use USB-C. That was pretty surprising that a governing body as large as the European Union would mandate a display.
Oh no, this has been something that's several of the companies involved with USB have been working with the International Standards Organization. And the problem is that in the old days, with a device, you would have a power brick that would have a certain kind of plug on it. When you got rid of that device, that power brick was useless, and you'd throw it away, and you'd throw away the cables.
Right.
So going years back, starting with the micro USB connector, there was a move to standardize on power connectors so that there was less waste in terms of power bricks and cables, and they could be reused. So the problem with the micro USB is there wasn't that much power. You couldn't recharge your Razor, for example. Right? Mm-hmm. USB-C was designed to overcome that. USB-C can provide up to 100 watts. So now smaller notebook computers and phones and even handheld Razors can use the USB-C for power. So the reason why USB-C has now been adopted by ISO is to become a standard interface for a ubiquitous power charging method. So you have one charger, one cable, and then a lot of different devices. So that's actually why that happened, was mostly for the whole. I mean, the motivation was for the e-waste and
Yeah.
the power brick situation. Yeah.
Yeah, and that certainly is an issue, and I can imagine in developing countries where you have all these different cables, and so much would just go to waste that could otherwise still be used if, of course, you have that USB-C standard. So, and kind of like we mentioned, and also here in the notes, USB-C supports DisplayPort alt mode. Did we mention that? And if we did, sorry to make you repeat yourself, but alt mode, what is that?
Well, so the USB-C standard was developed by the USB-IF, and USB has its own standard in terms of the data protocols, but then they decided that, well, let's add alternate modes, and let's allow a device where if it's discovered, if you connect a device that your host device can discover that it supports an alternate mode, then you could use what's called this alternate mode. So what DisplayPort alternate mode does is the USB connector effectively gets changed to a DisplayPort connector. It's a different plug, but it's using the same protocols. So for example, there's a passive cable that you can buy that has USB-C on one end and DisplayPort on the other end. And if you plug that into a DisplayPort monitor on the DP side, and then on the USB side, you plug that into a USB-C connector, like on a Samsung Galaxy or on a Dell computer, then it goes, oh, you're DisplayPort. Okay, so then it flips into DisplayPort mode. So it's really an alternate mode, but it's DisplayPort. So that's why when it comes to the USB-C connector, they call it DisplayPort alt mode, because it's an alternate mode for the USB-C connector. So that's where the name comes from.
I gotcha. Yeah, and of course, just poking around here, and this is something that, just kind of like a personal grievance. I've been seeing a lot of, let's say, internet service provider ads on TV lately, and they all say that, hey, if you want to do VR the best you can, you need the best internet speed so that you can do that. A lot of VR games, I would say the majority of VR games being played out there, most of them are, kind of done on your computer. They aren't really, they aren't really sent over the internet. You don't need to wait for any kind of latency, because really that's the big point, is that if you try to have a VR game that sent and received inputs online, the latency would just really take you out of the whole immersive experience and make it very uncomfortable. So I bring that up because the internet service providers are trying to say you need fast internet to handle, all this data. But I would think that a lot of this data that people are dealing with either through work, and I know that, there's a lot of stuff happening in the cloud and being streamed and stuff like that. But a lot of stuff, like, you just need good cables, good standards. Like, you need DisplayPort instead of, old USB-A or Type A or Type, whatever. Like, a lot of the innovations of that we're trying to get settled happen, I guess, kind of on the hardware level at people's computer right now, right?
Well, it's all about rendering. And so video is always the most challenging aspect of data bandwidth. And I don't know if you remember, but back in the early 2000s, it was unthinkable of having a whole movie stream across video. The cost would have been prohibitive, because you're talking about, several gigabytes of data. That was nothing, right? So the video that we're looking at, say for 1080p or 4K, is highly compressed. You take you take a lot of video data, you do a compression, and this is what gets sent across your cable or across your satellite link. If you're playing a game, you're actually rendering actual images that require a tremendous amount of data to be sent accurately to your screen. And if you're going at 144 hertz, I mean, you're going more than twice as fast, right?
Yeah.
So the interconnect speeds that we're using today is okay for compressed streaming video. But if you want frame-by-frame rendering for gaming, there's really nothing that fast over the internet that can support that today. Without a lot of compression,
right,
and latency, right? So, games, of course, will use local rendering in your PC, and it's communicating other aspects about the game, but you're not sending the rendered data. The rendering is actually done in your PC. So 6G could change that, right? Or,
Yeah.
I'm sorry, 5G.
5G.
5G. Yeah. Somebody said the other day.
16G is coming. Yeah.
Yeah, what is G and why do I need 5 of them? Anyway.
Right. No. They're absolutely right. And 5G has been a hot topic here on the show. Not so much because everyone says it's coming and things like that, but more of a personal grievance about, that's another standard that unlike what we've been talking about with like DisplayPort 2.0 and stuff like that, I fully believe that the industry is capable of putting DisplayPort 2.0 into devices over the next couple of months, over the next couple of years, and it will become a standard. I have no faith that the cell industry is capable of implementing 5G on a widespread basis. Like the reach, the availability of 5G, it's going to be overstated forever. It's going to take, the better part of a decade to actually get 5G to most people. But again, that's a topic that it's just 5G. But anyways, go ahead.
Well, you're right about that. I mean, it's easier for the phone guys to introduce premium phones with 5G, but then to go build out the infrastructure,
right?
All the towers. Yeah, that's the other thing.
Right. So one thing I wanted to bring up, and we're running really short on time, so I just really wanted to start getting some key points out there. First one, DisplayHDR monitor. What is that?
Well, so I guess you may have seen TVs to say HDR, etc. Mm-hmm. The high dynamic range, what that mostly means is that the contrast ratio going from very black to very bright. If you look at your window, I mean, your eyes are very adaptable to very high light changes. And displays up to this point have been up to, the brightness is what we call typically nits. Your screen will go to about 300 nits. Mm-hmm. Display HDR monitors, TVs will typically go up to about, the best TVs now go up to 1,000. So I have, 3 times the brightness for the maximum brightness. It's like if I'm, in an outside scene, or if I'm, if I'm inside a room that has darker colors, then you look outside, it's very bright, very realistic, the more brightness that you can provide. Now, with that brightness, you can also, with these TVs, get more color range. So, for example, in California, people may be used to seeing the green highway signs. Well, the typical monitor can't really represent that green. It doesn't have the color gamut that we call it. It doesn't have the full color range. So HDR monitors both bring you this high contrast for lifelike looking images and the wider color range. Now, a lot of products started saying we're HDR, but nobody really knew what that meant. So Vesa decided to set standards. And so we have a standard called Display HDR. And then we have different steps so that you can have Display HDR 400, 600, 1,000, and now 1,200. And or is it 1,400?
Well, and really, we're looking on the site here, displayhdr.org. We'll throw a link in the show notes. But we see CTS 1.1, HDR 1,000, and 600, and then kind of as you mentioned, 500, 400, blah blah blah. But yeah.
Yeah. So those are different brightnesses. Okay. And then, so basically, the best monitors right now are Display HDR 1,000, and we're going higher also. And then for OLED panels, we have a different standard, which is called Display HDR Black. And that standard takes advantage of the fact that OLEDs can go very dark. Basically, you can just turn the pixels off to make them totally black. So we worked with, display manufacturers like Samsung, LG, and then, AUO, and then monitor makers, we all got together to set these challenging standards that basically, they can meet the standards and they get certified to the standards. So then the user would know that, okay, good, this is a certified HDR 1,000 monitor. So I know that it's been tested and certified to be the performance that I expect. Mm. So this is what Vesa's done, is to try to basically weed out all the, the confusing garbage in the industry, to basically set standards so people know what they're getting. They want to, buy something that's better than they have today, that's HDR 400, or to get something that's actually better than that might really be good for gaming, would be HDR 600. Or if you're a content creator and you want to have the most accurate display possible, then you'd get HDR 1000. And each one is a price step, but these are standards. And then the CTS 1.1 is now for each of these grades. We're actually doing more testing. We made it a little more challenging. The technology for displays keeps getting better. So we've set the bar a little bit higher, and the new monitors now will be certified to this CTS 1.1. CTS stands for Compliance Test Spec. So 1.1 is the latest one, and that's the one that you should look for. And if you go to the DisplayPort, or actually the DisplayHDR.org site, you can see a list of monitors there that, we're actually changing the site probably this week. But anyway, you can see a list of monitors that meet that. So you can kind of, make sure you buy one that's certified and not one that the monitor maker is just claiming they meet the specs. You actually want it to be verified by Vesa, and then get the Vesa logo.
And really just something that I want to point out here, just because we're going to be doing this later. We have to reschedule them, but we're going to have ViewSonic on the show, and actually right here the ViewSonic XG27 or 270 QC. I actually have that setting upstairs ready to review, so I'm going to be trying that. And I'll be able to mention everything I learned here about it. Really display HDR, and you just helped me with my homework. So thank you so much. Now, with that being said, one other technology, and I know that this is, we've been talking a lot about computer monitors, OLED monitors. OLED is something that huge on phones. It's also huge in TVs, although I think QLED is gaining a little bit of presence. But OLED has been seen for the longest time as one of the best, acronyms that you can look for on a display. Now, how would you compare them? Like, would you say that display HDR is something that you might want to prefer over just strictly OLED? Because obviously, it seems like the two can kind of coexist.
Well, they do coexist. So OLED, or as people call it, OLED. So OLED basically uses individual LEDs that emit light, and the very color accurate. OLED monitors can't go as bright as, for example, a display HDR 1000 monitor, but they go much, much, much darker. So if you're in a brightly lit office environment and you want to have a lot of dynamic range, you might be better off with a regular display HDR monitor. But if you're in a home environment, or if you could just subdue your light even a little bit, then OLED really provides a very, very nice environment. Very, very brilliant colors, because with the light being darker, you don't need that high brightness. So Vesa has standardized what's called Display HDR Black, which is specifically for OLED monitors. And so you can get Display HDR with OLED as well. And again, the only difference may be is if you're in a really, really bright environment, OLED's not going to, it goes up to 600 nits, where with the Display HDR displays, they go up to 1,000 or even higher. So you get that extra light, and then you're in a bright environment, you're not going to be taking advantage of the blacks anyway. So you actually get more dynamic range in a regular Display HDR monitor. But if you're in a if you're in a home environment, or not such a bright environment, OLED is really a nice experience. I mean, it gives you, well, there's some advantages where you don't get blooming like in around a bright dot on a black scene. On an LED monitor, you can get a little other light leaking through, where OLED you won't, right? OLED, those pixels are on, everything else around is off. So you get really nice contrast. And so OLED monitors are great. And we're going to see a lot more of them. And basically, PC manufacturers are going to be increasingly adopting OLED, and phones, as you see now, Samsung, now Apple, and others. So OLED's, definitely something that's coming in displays, and definitely something people should look at.
Absolutely. Yeah. So, and unfortunately, we're just about out of time. And everyone, we've talked to Mr. Craig Wiley, Senior Director of Marketing over Parade Technologies and Vesa board member. And actually, speaking of that, real quick, because that is, kind of your parent organization, or at least the one that you work for. Parade Technologies. What is that, real quick? And yeah.
Well, we make chips, and we make chips that help drive the interfaces for DisplayPort, HDMI, PCI Express, USB, and basically we make signal conditioning chips. These signals now are up in the gigahertz range, so they require conditioning, sometimes require repeating. And we also do the chips that go into displays. So we'll take the DisplayPort signal and basically drive the panel. So we work with a lot of panel manufacturers on the display side. So we're a chip company.
I gotcha. No, and hey, that's I can definitely see why you're so passionate about really about displays, and you've given us a lot of information, and a lot of this is going to be applicable, I guess, in the coming years and really the coming months. Just and really Vesa compliance and more so DisplayPorts. Anything, and trust me, I'm sure that there's a lot that we didn't cover. But how about just parting statement? If people are out there looking for a new, let's say, monitor or TV, or actually, because the DisplayPort, as we mentioned, is kind of more around PC. Let's say people are looking for a new monitor for gaming, for personal use. What should they look for first and foremost?
Well, I would say that they'd want to look at the DisplayHDR monitors. Those do provide the best visual performance. Of course, depending on the application, then they want to look at frame rate. If it supports FreeSync or adaptive sync or whatever. But there's more of that to come. Now, Vesa will also be standardizing adaptive sync as well. Mm-hmm. In the future, but I would say that first of all, a monitor, if they're not into gaming, then they don't need to worry about refresh rates as much. If you're into photography and video, display HDR, you don't need the frame rate. If you're a gamer, then certainly the frame rate is a big advantage.
Right.
And display HDR will actually, add more pop to the game just because of the higher contrast. The flashes will be brighter, things like that. So I would say those are the things to look at.
Thank you so much. We actually have one of our regular correspondents. He works out in a large studio for Hollywood, and his big thing is always like whenever we talk about a new graphics card, or I should say actually a new monitor, his big thing is always color accuracy. How accurate is the color? And he'll spend a lot more money than I guess the average consumer would based on that color accuracy. Right.
Well, and display HDR, actually, that's one of the test criteria is color accuracy, not just range.
Right.
Especially the higher, like display HDR 1000 and the categories above that. Color accuracy is a very big part of it. And so, yes.
I'll be sure to mention it to him. And in the meantime, everyone, as I said before, computeramerica.com will have links in the show notes to everything that we talked about here with Craig. And Craig, thank you for your time. And really, this was... as I said before, I knew this was going to be interesting, and you did not, disappoint. So thank you so much for coming on Computer America.
I really am glad to be here, Ben, and if you have any other questions, don't hesitate to call anytime.
We'll be sure. So until next time, have a great day, and we're going to go ahead and continue with computer and technology news, but we're going to say good, have a good day, Craig. So have a good day.
All right, thank you.
All right, everyone, and here we go. We're going to go ahead and do computer and technology news brought to you by Computer America, and why don't we go ahead and get started. There we go. Boy, I really should have been more prepared for this. So everyone, computer and technology news, this is where we try to keep you up to date on all the latest. And everyone, how about we talk about Facebook for a little bit? I know, the air just got sucked out of the room. And let's see. So this is going to come to us from Fox Business, but they mentioned that IRS sues Facebook for about $9 billion. Check that out. About $9 billion in unpaid taxes. And if you're wondering, well, hey, how the heck did they get away with that? Something that I'm sure that a lot of people in the tech industry are looking at this and going, well, they can sue Facebook, but are they actually going to get it? Because if you don't know, there are a lot of tech companies that you think are American that actually have their headquarters, their global headquarters, in Ireland. And Ireland has long been known to be one of those tax havens where the tax rate and you're still a member of the European Union, although of course that has changed just recently, but having your headquarters in Ireland meant that you got to participate in this larger market, and the tax rates were some of the best in the world. So it was common practice that no jobs are shipped over, no buildings are actually built, but you simply say that you are operating out of a certain address in Ireland, and you get to take advantage of all those juicy tax breaks. So let's go ahead and get into the story. And as I said before, Fox Business saying that Facebook is slated to begin a tax trial in San Francisco court on Tuesday as the Internal Revenue Service tries to convince a judge that the world's largest social media company owes more than $9 billion linked to its decision to shift profits to Ireland. And they mentioned that they expect to take 3 to 4 weeks, could see top executives testify, and of course, we'll see if they're able to convince. So they mentioned that the IRS argues that Facebook understated the value of the intellectual property it sold to an Irish subsidiary in 2010 while building out global operations. And again, a lot of people did this. It's just no one really actually operated out of, Ireland. They said that Ireland has lower corporate tax rates than the United States, so the move reduced the company's tax bill. Let's see. So yeah, they lowered their tax bill. Under the arrangement, Facebook subsidiaries pay royalties to the U.S.-based parent company for its trademark, and from 2010 to 2016, Facebook Ireland paid Facebook US more than $14 billion in royalties and cost-sharing payments, according to the court filing. So what's happening there is that, as I said before, nothing's actually developed, no jobs are moved, nothing really happens in Ireland, except that they get to keep all the profits. Like, they pay a certain amount of royalties, so they got their $14 billion for operating, and they can, spend that money in operation expenses. But then the $9 billion that would be taxed as profit from the company, the $9 billion sits in an Ireland account and is taxed at a lower, whatever the Irish rate is, 10%, 15%, whatever it is, much, much lower than the corporate rates. So they said that Facebook Ireland and Facebook's other foreign affiliates, not Facebook US, led the higher risk and ultimately successful international effort to sell Facebook ads. That's what the company is arguing, at least that's what Facebook is arguing, that, Facebook Ireland is necessary, crucial, absolutely, although not really. So Facebook is the world's second biggest seller of online ads after Google. Monthly users of its core social network climbed 8% to 2.5 billion users in the fourth quarter, while 2.9 billion people used one of its apps, including WhatsApp, Instagram, Messenger, and Facebook. And by the way, everyone, that's every month. Almost 3 billion people use a Facebook product. That's crazy. So if the IRS prevails, Facebook would face an additional federal tax liability of up to $9 billion, plus interest and any penalties, the company estimated in a recent securities filing. So hey, we're going to have to see what happens, and I said that we're going to be very, very interested because it has to do with, I know that Apple has an Irish headquarters, and I know that, and I think Amazon does as well. A lot of these companies do the exact same thing. So Facebook is the first. A lot of them are going to follow after. Okay, so let's go ahead and figure out what we're going to talk about next. Let's talk about. This is pretty interesting. A new world record. You like those? A new world record for the conversion of solar energy to electricity using quantum dots. We've talked about the quantum dot technology. That's the technology that, of course, goes into the QLEDs from Samsung. Although the quantum dot technology has been developed since since the 1990s. It's been around for a while. So they mentioned that the University of Queensland in Australia, researchers set a new world record for the conversion of solar energy to electricity via the use of tiny nanoparticles called quantum dots, which pass electrons between one another and generate electricity current when exposed to solar energy in a solar device. Let's hope that they actually get into the number. Yeah, they actually do down here. So they mentioned, the lead researcher mentioned that the conventional solar technology uses rigid, expensive materials. The new class of quantum dot technology that the university uses are flexible and printable, so hopefully cheaper, which is a big part of it. So they mentioned that the new generation of quantum dots is compatible with most affordable and large-scale printable technologies, and that the near 25% improvement in efficiency we have achieved over a previous world record is important. It is effectively the difference between quantum dot solar cell technology being used exciting prospect and being commercially viable. So the world needs to rapidly reduce carbon emissions. We all know the reason why we need solar electricity. They mentioned that harnessing the power of fundamental technological and scientific research is a big part of this process, and that's what we're focused on at UQ. I'm trying to think what would be the downside, like what would be the drawback? Why don't we have this now? And the only thing I can think of is that even though they mentioned that it's compatible with many large-scale printing operations, cost generally seems to be one of the main reasons why you don't do these kinds of things. So, yeah, potentially it could be a cost problem. But 25% increase. I wish. Let's see. So I think they found another article here. Hopefully we can see if they actually wrote how efficient it actually is. But eventually, solar power is just going to be the clear winner. I mean, the sun's always shining, and if it isn't, wait a couple hours, it should be shining again before you know it. It's just the way to go, and especially in Australia, they have a lot of sunshine. So, okay, Brett, last one. I like innovation. I like high technology, and let's see. And let's go ahead and mute this before it starts. Brett's develop a 100,000 mile per hour rocket that could cut the trip to Mars by half. And obviously not distance, but hey, at least in time. So this is actually a plasma. It's a plasma-powered rocket engine. And they mentioned that So here we go. A pulsar fusion Pulsar Fusion is the company, ultimately hopes to construct an engine capable of powering rockets and traveling at a staggering 500,000 miles per hour. Pulsar, a privately owned nuclear fusion firm, I can't believe we even have those, the future is now, based in Bletchley, which of course is in London, has constructed the miniature version of the thruster, and the trial opens up a range of tantalizing possibilities, as well as underscoring the importance of post-Brexit Britain of the soaring space sector, which also celebrated the launch of the Solar Orbiter spacecraft earlier today. Yeah, so unfortunately, I don't think we have enough time. We're about to, kind of head off here, but it's pretty cool. Let's see. So any other stories real quick that we should probably just mention the headline of? Internet Society to halt .org sale by its own advisory council. That was a big thing. The organization behind the .org was about to be sold to a for-profit organization who said that they were going to simply streamline the process, but of course the distribution of .orgs could have been severely limited or opened up, both of which probably bad. Let's see. U.S. Navy orders AMD Nvidia-powered supercomputer with 590 terabytes of RAM. Think about that. This one's pretty cool, and we'll go ahead and throw all these in the show notes if you'd like to read more about them. But yeah, Let's go ahead and read that again one more time. U.S. Navy orders AMD Nvidia-powered supercomputer with 590 terabytes of RAM. And they mentioned that Cray, which I think was purchased by IBM. But yeah, so IBM, but Cray is building a machine for the U.S. Navy that is packed with AMD's EPYC Rome cores and Nvidia's Volta GPUs. Built on the Shasta platform, it'll boast a performance of 12.8 petaflops. Think about that, 12.8 petaflops. That is insane. Yeah, which makes it one of the top 20 most powerful supercomputers in the world today. The Navy can buy some really cool toys with all that money, but there you go. So as you would imagine, the supercomputer will feature some serious hardware, including 112 NVIDIA Volta V100 GPUs, 200 gigabit per second Cray Slingshot network interconnected, and of course, 290,304 AMD EPYC 7002 series processor cores. Let's see, there will also be incredible 590 terabytes of memory and should be enough for a few Chrome tabs and 14 petabytes of usable storage, including 1 petabyte of NVMe-based SSDs. Incredibly fast. So hey everyone, that's about it. That's all the time we have here for today. Thank you so much for tuning into Computer America. Thank you DisplayPort and Vesa for being on the show. It was a lot of fun. And hey, check us out next time, 4 p.m. to 5 p.m. Eastern, Monday through Friday. Until next time everyone, have a great day. Thank you so much. We'll catch you then. Bye everyone.